Hello, Mr. Eric. How are you today? Good. Okay. So today we talk about a program. How do you multiply two integers?
Numbers.
Yeah. Can you write the function to multiply two integers? Very simple. I write the top for you. Define, multiply.
Why is it so simple?
Yeah. A and two integer. A and B. What's missing?
Column.
Okay. And then what? Can you write it? Return what?
A times B.
Return A times B. Oh, you're so lazy. You don't even want to write this. Okay?
It looks very short.
It looks very short. Okay. How about I tell
Very
you?
easy to remember.
I tell you, you can't use times multiply, and you can't use the multiply, and you can't use the division, and you can't use any bit shifting, which you may not be familiar. You know the bit shifting. We'll talk about that later. Okay. So can you figure a way to implement this function without using these two? And bit shifting like or, and, shift, left, shift, right. Okay? So you can't use any of these. Can you figure out a way how can we write it? So for example, given 3 times 5. How do you calculate 3 times 5 if I don't want you to use the multiple? How do you?
5 as 5 as 5.
5 at 5. Well done. That's the good shot. Yeah. So basically, we turn in the multiplication into. You can do it 3 times 5. Yeah. Or 5 times 3. Alright? Yes. So which way you think it's the most efficient way?
5.
Why is that?
Because it's more short.
It's shorter, so it involves less operation, right?
Yeah.
Yeah, okay, that's good. Okay, how about the negative numbers? Negative numbers. Like, how do you handle these negative numbers? Like multiply minus 3 times 5, minus 3 times minus 5. Yeah? And then if there's zeros, for example, like 3 times 0. So
Then definitely 0.
yeah, I know. So how do we implement this?
If
they're negative, what do we do?
If they're negative, if 2 negative, do we just turn into positive?
Well done. Yeah, 2 negative turn into the positive. And how about 1 negative? What do we do? 1 negative.
1 negative.
So minus 3 times 5 equals what?
Minus 3 times 5. Minus 15.
Yeah, minus 15. So how do we do it? If there's a minus, then we take a minus.
Away.
And then we check this and put a minus. Okay, so let's write it. Okay, so easy. Look, it should be very easy. So look, if A equals 0 or B equals 0, return what?
0.
If A smaller than 0 and B smaller than 0, what should we return? Return, let's call it self, yeah? Let's turn this negative into positive, which is return multiple what? Can you fill this blank to think?
Turn into positive?
Yeah, how can we turn it to A is negative, now how can we turn it into positive? A is already negative. How can we turn A into positive?
A negative. Wait.
What? Minus what?
A?
Yeah, minus A, and here?
Minus B.
Yeah, minus B. Okay, be confident. Okay.
Minus B.
Yeah. Okay. Then look, if one of them is negative, if A smaller than 0, B smaller than 0, can you tell me what to put here?
What?
Can you? This is
I
N.
thought you said you can't use and.
We can use not the N. This is logical and not the bit shifting. You can use this. So if A is smaller than 0, what? This we checking if both are 0. And if at this point both are not 0, right?
Yeah.
And both are not 0 if what should we put here? If one of them is 0, should we use N or O? If one of them is 0, what should I put here?
Or
Oh, yes. If one of them is 0, but we need to check which one is 0, so it's better. If a smaller than 0, then what? Return what? If a smaller than 0, is b smaller than 0 in this case? Is b small? No, because if a smaller than 0, b smaller than 0 is here, yeah?
Yeah.
If a smaller than 0, return multiply what?
return multiply a
small
minus
and
b.
yeah. Okay, well done. If
B.
b smaller than 0, yeah, return what? Multiply.
Minus
B is smaller than 0. A is smaller than 0? No.
no.
Then return.
A and minus b.
Well done. Yes. Okay, so basically these are the
So
cases.
many f's.
Yeah, these are the cases to turn everything into positive because we are focusing on handling the positive multiplication for two numbers. Yes.
Yeah.
If any of them is 0, we don't care. If any of them is negative, or both of them are negative, we don't care because we have these 4 ifs to turn everything into positive. Okay?
Yeah.
Turn everything into positive. Positive A. Positive. Okay, so now positive. How can we do this?
Power.
And look, if A is smaller than B. Okay, so we want to turn 3 times 5 into we want to turn 5 times 3 into 3 times 5, right?
Why?
So instead of 3 plus 3 plus 3 plus 3 plus 3, we want the 5 plus 5 plus 5, okay?
Yeah.
Okay, so suppose this is A, this is B. So if
If
A
A
is bigger than B, then return what?
return
Multiply what? We
B.
want to.
A.
Well done. Yes. And now we are following at these cases. So A is 3, B is 5. So how can we do it? How can we write it? Okay, we can return what? So 5 times 5 times 5, yeah. So we want to make
add.
we want to make A smaller. 3 times 5 equals 3 minus 1 times 5 plus 5. Alright?
Yeah.
Yes? Yeah, got it? So how can we write this?
A minus 1 times B add B.
Look, we can't use these terms. So we need to use this multiply. Return what? Multiply what? Multiply what? This is A, this is B. Multiply what?
A minus 1 multiply?
No, it's the A and B. What?
Okay,
B, yeah?
okay, B add B.
And then add B, yeah?
Okay.
Well done. Now that's perfect. Okay. So how can we turn these? If we don't want to use this recursion, we want to do it using iterated. How can we do this? So we add the answer here. Answer equals 0, right? Yes? Yeah? How can you turn this into a while loop?
While
While A what? Is bigger than what? Why I is bigger than 0, right?
Yeah.
And what should we do? Answer plus equals what? Can you do this?
1.
1?
No.
Answer plus equal what? We are adding what?
1.
1.
No, I'll read. A.
Why A is smaller than 0? A is 3, B is 5. Why A is 3 is bigger than 0? We are adding the answer of what?
B.
B. And then we need to
I
decrement.
could get that.
And we need to A what 1?
A.
Become 2. So what? We need to make it
Minus.
equals 1. Okay? And then
What?
return what? Return what?
Other.
Well done. Okay, so do you see it? Yeah? Yeah, we are using only the plus, minus to deal with the multiplication, right? Yeah? Good, okay?
Yeah.
Yeah. So how about as a bonus, if we are allowing to use the division or shifting, how do we do it?
You have to use those.
No. This is because my original question is don't use the time multiply and divide and bit shifting, which is to the left, to the right. But to the left, to the right is basically to the left is basically multiply 2. To the right is basically divided by 2. Yeah, got it? Because look, one this is in binary is a. Yeah, if you get rid of 0, that becomes 4. Yeah, shifting to the right. If you add one more 0, it becomes 16. Yeah, got it?
Yeah.
Okay. So if we are allowed using this any sorts like 3 times 5, how can we do it? 3 times 5 equals what? Equals
3
what?
times 5 equals 15.
Yeah, I know.
5 and 5.
Maybe a little bit. Yeah. Maybe a little bit. Maybe look. Maybe
What?
6 times 5 equals
30.
what? Yeah, I know. But
5 and 5 and 5 and 5 and 5.
no. Maybe 6 times 7. Okay. How do we do it? This is A. This is B. Instead
Yeah,
of adding 6 times of 7, 7 plus 7 plus 7 plus 7, we can do this. We can because
we can divide this into 2.
and multiply this by 2. Yeah.
Yeah.
So that will become 12 times 14. 3 times 14. Yeah.
Yeah.
So that will be even shorter. Yeah. But if it's an odd number, so we cannot use this. We can minus 1, right? When it's even number, we can divide A by 2, or shifting the A to the 1 to the right, right?
Yeah.
And then multiply B by 2, or shifting B 1 position to the left. Got it? So this case it will be faster, right? Instead of what's the time complexity of this one? By the way, O what?
It looks like
O which one? O what? A or B?
A.
Yeah, O A. But in A, because A is smaller, right? Yeah, O is smaller, so you can O mean A B. And because A and B could be negative, so you put the absolute value. Yeah, this absolute value. Remember ABS?
What's absolute value?
Remember, absolute minus 3 equals 3 is the distance between the number on the line to the 0. Yeah. In mathematics, you use this to. This minus 3 equals 3. This 3 equals 3. So it's like 2 vertical sticks. Okay? Okay? Yes? Yeah. Minimum absolute value AB. Yeah? This is the complexity. Yeah? Because we need that amount of time, iterations to calculate, to accumulate another value. Am I right? Yes? If we are using this divided 2, what's the complexity? It will be log thing, right? Because every time we can divide it by 2.
Yeah.
Yeah, so there will be log minimum.
Can we only divide it by 2?
Yeah, because log divided by 2 is the most efficient, okay? Yeah, got it?
Yeah.
But that's a very good question. Yeah. Okay, so that's it for today.
Bye!
Have a nice weekend. Bye-bye.
Bye!
Yeah, bye-bye.